Hey everybody, welcome back. Today we're going to talk about the distance between two planes. This is in chapter 11 of the calculus book by Anton. So this is calculus 3 at College of the Sequoias. Let's just jump right into it, get this part done, and get on to an example. So we want to find the distance between two planes. We're going to start with a plane, and we've got some point P naught that's in the second plane. I didn't have it depicted here because it gets in the way. Now we want to find the shortest distance to the plane below it, and since they're not necessarily easy to find Q, what we're going to do is we're going to project some point Q that we don't know what it is, X, Y, and Z, a vector from Q to the point P naught in the other plane. We're going to project it onto the normal, and that way we can find this distance right here. So we're going to work with projections. And if we do that, we are going to end up with the formula AX naught plus BY naught plus CZ naught plus D, the magnitude of it, divided by A squared plus B squared plus C squared, or the square root of. And what do we know about that? That's just the norm of the bet. It's the distance of the norm on the bottom. So let's just prove it using projections. We're going to pick a point Q in that plane later on, but right now we're just setting up the formula. So QP naught, we're projecting vector QP naught onto N. We know the formula for projections. It's the dot product divided by the norm squared times the magnitude of the norm. And so we can cancel out magnitude of the norm here with one-on-ones on bottom, and we just have this formula. So how did we get this up here? Let's take a look at it. If I do QP naught dotted with N, well, N is going to be ABC, because we're going to use this formula right here for that plane. We talked about how that worked before, N being the coefficients. We're gonna substitute, we're gonna treat Q as this X1, Y1, Z1, and X naught, Y naught, Z naught will be in the second plane. So if I dot those two together, I've got A times X naught minus X1 plus B times Y naught minus Y1 plus C times Z naught minus Z1 equals, we're focusing on the X naughts right now because that other point's really the one that matters for the distance between the planes. I've got AX naught plus BY naught plus CZ naught plus D. D combines the remaining portions of A times negative X1, B times negative Y1, and C times negative Z1. So we can see D right there. We're not going to worry about it. We're just going to use it from the formula. Okay. So let's take a look at what happens. The bottom, we know what it is, obviously. The magnitude of N is A squared plus B squared plus C squared. If we wrap all those up as D, we have our formula. Okay. Let's take a look at an example. We're going to find the distance between two planes here. And we're going to use plane A is 2x plus 5y minus 3z. And plane B is negative 4x minus 10y plus 6z. The constant for plane A is 1. The constant for plane B is 6. Okay. So I have these two planes. They are parallel. So they have the same normal vector. If they weren't parallel, the closest distance between them would be where they intersect, obviously. So they have to be parallel. So let's just look at the N. The normal vector for A is, remember, it's the coefficients on our variables, 2, 5, and negative 3. B is negative 4, negative 10, and 6. So I can write that as negative 2 times the normal for plane A. And the one on A is the most simplified version of it. 2, 5, and 3 are all prime numbers. We're going to use that one as we do stuff. So how do we go about finding this distance? Step one, pick a point that's easy to work with on one of the planes. Now, this is what I did. I went through and I looked through all the coefficients and the constant and went, if I zeroed out any two variables by making like setting equal to 0, will I get an integer remainder when I solve for the variable? If I use anything from plane A, if I zero out y and z, I get x is 1/2. If I zero out x and z, I get y is 1/5. If I zero out x and y, I get z is -1/3. I don't like those. I don't like working with fractions if I can avoid it. On plane B, if I zero out y and z, I've got 6/-4, again, a fraction. If I zero out the x and the z, same thing. 6/-10 is ugly. And if I zero out the x and the y, look what I got. 6z = 6. I like that. That gives me an integer remainder. So I'm going to run with that one. 6z = 6 is easy. So we're going to set x is 0, y is 0 in plane B. Solve, and we can see with z = 1, we get a point. P0 will be 0, 0, 1, and that's in the second plane, plane B. All right, so step 2, we've got the plane. This is going to be the values that we plug into that ax0 plus by0 plus cz0 plus d. That's our x, y, and z. So we need to get that top portion. Ideally, you want to use the most simplified version of n that you can. It makes the math easier. Why use -4, -10, and 6 when it just makes all the arithmetic produce bigger numbers? So I'm going to use the 2x, 5, or 2, 5, and -3. And I'm going to use the equation that goes with that one. Or if it's not one of the planes, I'm going to, if like this most simplified version of n is something with one of these with all like 2 divided out of everything, for example, I would use it. Right now, it's the most simplified one. I'm going to solve so the right side equals 0 so that I get that ax plus by plus cz plus d. And that's what I did. I subtracted 1 over from the left, or from the right to the left, and that's going to give me my ax plus by plus cz plus d. That's going in my top part of the formula. As a reminder, the formula is ax plus by plus cz plus d on top. And on bottom, we have the norm of n. So we're going to use those. We already know what n is. It's 2, 5, 3. We're going to use this plane, and we're going to use this point. So let's do the math. I replace a, b, and c. I plug this in here. 2x plus 5y minus 3z minus 1. And then I'm replacing x, y, and z with my P0. Okay? And on the bottom, we're just doing the norm of n. Again, using the most simplified one. So we want to use the one that matches the numbers up here. Okay? I get on top the absolute value of -4 over the bottom, which is the square root of 38. So this is 4 over the square root of 38. 4 over square root of 38. Square root of 38 is a little bit larger than square root of 36. So the bottom on the left here is larger. So this would be smaller than 4 over square root of 36. Larger on bottom means the overall number is smaller. And I know what that is. That's 4 over 6. This is a little bit less than 2/3 if I really need to know it and I don't want to get a calculator out. Or get an approximation, I should say. That's the actual distance, though, and we want to write that in units. 4 over root 38 units. And that'll be it for this video. Peace.